Okay, welcome back. Lesson 33, Geometry, Points, Lines, and Angles. So, congrats, you have made it to the final segment in this pre-algebra course, and I hope that you will find beginning, intermediate, and college algebra on iTunes U and various other courses. If you're climbing up that ladder, I hope that will help you. So, geometry, much like any other course, has its own set of vocabulary, and in these lessons, these last two lessons, lessons 33 and 34, we're just going to skim the surface of geometry and do some fundamental definitions and calculations. But like I said, the course itself is much deeper than that. But let's get started. So our first vocab word is plane. A plane as a theoretical concept, it's a flat surface that extends indefinitely in all directions, north, south, east, and west. Now, if you want an easy way to picture a plane in your mind, just picture like the walls and the ceilings and the floors. So here's a plane, and you're noticing two planes intersect along a line. Okay? Now, if you throw in the ceiling as a plane, okay, where do three planes intersect? Where do those three planes intersect? And what's neat is you can see it. All three of those planes come together where? At a corner, at a point. So three planes intersect at a point, two planes intersect along a line. Okay? That just kind of helps you get a visual that a plane is a flat surface. Now let's get another word under our belt, which is a point. The most basic concept of geometry is the idea of a point in space. A point has no length, no width, no height, but it does have a location. And we will represent a point with a dot and give it a letter name, point A. Little bit of notation here. If you take 2 points, A and B, and connect them with a line, notice the arrows. We can call that the line AB or the line BA. So I do want to talk notation-wise. If I want to name this line, I can name it AB with this over it, or I can name it BA with this over it. A segment has a beginning and an end, so I could name the segment AB with this over it, or BA with that over it. An array has a beginning but no end. Notice how it goes indefinitely that way. And you have to name it the direction of motion. AB with this over it, right? I cannot say BA. Notice how I'm going to wipe that out. No. I cannot say, I have to name this one AB. Okay? So that's just a little notation help, the difference between line segment, and ray. Line goes indefinitely in both directions, segment has a beginning and an end, and ray has a beginning but no end. All right, now an angle is made up of two rays that share the same endpoint called the vertex. So you see here the common point called the vertex. We can name an angle, this angle here, we can name it ABC, CBA, plain old angle B, or angle X. So there's different notations. An angle can be measured in degrees, and there are 360 degrees in a full circle. So if it's been a while since you've used a protractor, I have some drawings here that I want to add to. This is said to be the initial side of your angle. Here's your vertex. So if you're using a protractor, when you go to measure your angle, you go counterclockwise from the initial side to the terminal side. And notice you would grab this, not the 120. Don't look at the 120. 60. See, that's a 60-degree angle. It is an acute angle. And it makes sense because we know from the gate that here's 90 mark. We know that whatever the measure of that angle is, it's definitely less than 90 degrees. We know that, before we even get a protractor out. Likewise, take a look at this one. The mouth opening from the initial side to the terminal side, whatever it is, we know that it's definitely greater than 90 degrees, that it's obtuse. We'll talk about those words in a moment. It's 140 degrees. Why? Well, make sure you grab this number and not this number. So if it's been a while since you've used a protractor, I just wanted to reiterate that. So we have a 140-degree angle, making it obtuse. Now, if it's been a while since you've seen those definitions, acute and obtuse, let's take a look at the next slide. Acute angle is between 0 and 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is between 90 and 180, and a straight angle is exactly 180. As you are classifying angles, I also want you to get comfortable with the words complementary and supplementary angles. Complementary angles have a sum of 90 degrees. Supplementary angles have a sum of 180 degrees. Little note, so if I ask you, what is the complement of a 40-degree angle? Question. You will say, oh, 50 degrees, right? Because 50 plus 40 makes 90. Keyword complement. Okay, now let's try again. What if I ask you, I'm going to type it, what is the supplement of a 50-degree angle? And let me scoot this question down. So hopefully you're thinking that the supplement of a 50-degree angle would have to be 130 degrees. Why? Because 50 plus 130 makes 180, so they would be supplementary. Okay, so just getting you comfortable with the language. Now let's go to the next slide. Parallel lines. In your mind, you're probably thinking that two lines like train tracks that never intersect are parallel, which is true. And then you're also thinking that intersecting lines intersect at a point, and when they do intersect, they form four angles, right? Okay. Also bear in mind that if you have two lines that are perpendicular, then they have to form right angles when they intersect. So that's a very special case of intersecting lines. They intersect at that perfect right angle. Notice the notation. N is perpendicular to M. This one is P is parallel to Q. So notice the notation for parallel and perpendicular lines. We have a little bit more vocabulary before we can start doing some computations. Adjacent angles are angles that are basically side by side and are supplementary. So now I'm just making this up. If A, big note to self, if A is 140 degrees, then B is blank. Well, if this is 140 degrees, what's this? Well, it's got to be 50, because 50 plus 140, oh, sorry, basic math error. It's got to be 40. Why? Because 140 plus 40 makes 180. 140 plus 40 makes 180. So this will have to be 40. Okay? And now you know, I mean, if this is 40, then from here to here would have to be 140. And from here to here would have to be 40. So you can kind of fill in the blanks. And then you start to notice that, gee, these angles that are across from each other are always equal, 40, 40. And they're called vertical angles. But you start to notice these things. So again, big thing is that adjacent angles are supplementary, and these angles across from each other at the intersection, called vertical angles, are congruent, are equal. Hold all this in your mind, because we're about to sort of fill in the blanks here in a moment. If two parallel lines are cut by a transversal, I want to talk about that. If you have two parallel lines cut by a transversal is just this line shooting through them. How many angles are formed? So the first thing you start to notice is 1, 2, 3, 4, 5, 6, 7, 8. 8 angles are formed. and they probably have certain relationships with each other. So let's see. Corresponding angles. Well, here we name pairs of corresponding angles. A and E are corresponding. And just take note of what that looks like in your own mind. C and G are corresponding. And if they're corresponding, they're equal. And that's big. So that means whatever angle C is, so too is angle G. And whatever angle A is, so too is angle E, etc., etc. And we have that mapped out here. Hold that in mind, what corresponding angles look like. Now we have alternate interior angles. And notice that where they are. Angle C and angle F are equal. This one and this one. But angle D and angle E are equal. Okay? But now that you know this terminology, let's throw it all together. Fill in the blanks. So if we're given that angle B is 82 degrees, don't we inherently know all the rest? Yes, we do. So let's think about it. Here's an angle A is adjacent. Just kind of think about this logically, to 82 degrees, so it's got to be 98, right? Because 98 and 82 will bring us to 180. Let's map what else we know. We know B and F are, angle B and angle F are corresponding. So I'm going to write that here. Angle B and angle F are corresponding. And guess what? If they're corresponding, you know they're equal. So this is 82 degrees, and so on and so forth. Then you know that this has to be 98. You also know that because it's corresponding with this one. And then, once you know that this is 82, you know that this is 98, you know that this is 82. Why? Because G and H have to be, supplementary. So it's like a puzzle, and you can thereby fill in all the blanks. You know that if angle B is 82, you know that angle C must also be 82 because they're vertical angles. You know that D must be 98. And you can just kind of think through where those numbers came from. All right, hope that helps you dissect. Let's take a look at the next slide. Oh, we made it. That was our last slide. So, okay, really just practice naming. I would say the big thing is I want you to practice not so much the numbers and everything, but naming what they're called. So let's just practice a little bit. A and B, what are they called? They're called adjacent. And that means that they're also supplementary. I'm just going to throw you a couple, see if you catch it. Okay, what about D and E? Well, those are alternate interior. So you just want to kind of throw yourself some combinations and see if you can talk about what they are. All right, hope that helps. That is the end of lesson 33. You will see perimeter, area, and volume calculations on the next geometry and the last geometry segment. Good luck out there.